You're listening to the Knowledge Archives podcast. Welcome to the Knowledge Archives podcast. We're a group of students on a mission to learn from as many different disciplines of knowledge as possible. I'm your host, Madhav Malhotra, and today I'm glad to be joined by Dr. Jesse Reynolds, a scholar on the topic of geoengineering and especially its international governance. He's had a lot of experience with this topic, including at the UCLA School of Law in the US and the Utrecht Center for Water, Oceans and Sustainability Law in the Netherlands. I'm very excited to learn more about this urgent topic today. So thank you for joining me today. I really appreciate you taking the time, and I'm very excited to learn about this increasingly important area. And I know that we'll be diving a bunch into some of the more complicated details as we go on, but before we started, I'd love to just hear a little bit about yourself and how you really got involved in this area of work to begin with.
Great. It's good to be here. So my name's Jesse Reynolds. My title is Emmett Frankel Fellow in Environmental Law and Policy at the University of California, Los Angeles School of Law. And I am a researcher in the governance of environment and technology, particularly at the global and international scale. And so lately, this has involved a lot of work in what's called geoengineering or climate engineering, which we'll talk more about. I've also been dabbling a little bit with some new biotechnologies that are aimed toward intentionally modifying the genomes, the genetics of wild species. And if you think, and one can think a little bit and say, okay, that's sort of like climate engineering in a certain way, intentional modification of outdoor systems. And I ended up here. Well, I suppose I took a little bit of a somewhat of a detour. Back when I was a bachelor's student, I studied the natural sciences, chemistry, and environmental sciences. When I moved on to my master's, I transitioned to environmental policy. And then I spent a decade outside of the academic world working at an advocacy organization that worked on issues of the policies of human genetic and reproductive technology. So one can think about cloning and genetic modification of humans and that sort of stuff. And I went back to academia, got my PhD in this topic of the governance of geoengineering. And since then, I've remained in the academic world and ended up here as a research fellow at UCLA.
Yeah, I think it's incredibly fascinating to hear about all of these different topics, but also what is common between all of them in terms of the governance of these kinds of fields. So I'm very excited to dive greater into detail about one part of that in terms of geoengineering. And to begin with, I know that for a bunch of people, this will be maybe a sci-fi concept they might have seen in some kind of documentary or movie, but not really understand the gravity of
Yep.
why this is something we need in the first place. So could you describe how confidently we know that we will have to embrace some form of geoengineering to be able to meet our climate goals in 2050 and so on?
Sure. So the context we're working in is climate change, human caused climate change, which you and I'm sure many listeners know is caused by our emissions of greenhouse gases, especially carbon dioxide, from all sorts of modern industrial activities, mainly burning fossil fuels, but not just that. And these have accumulated in the atmosphere. They don't just go away after a couple of years. Carbon dioxide stays in the atmosphere for a long time. It's been accumulating really since the Industrial Revolution, but especially over the last 50, 60 years. And it poses a wide range of very serious risks to people in the environment. And what motivates me is that these risks are especially borne by people who are already vulnerable. So the world's poor are the most vulnerable to climate change. And that's what motivates me in my work. Climate change as an issue was first identified and taken seriously, let's say in the early 90s. And there was the first global agreement to start taking action to reducing greenhouse gas emissions. And perhaps this has happened emissions have reduced to some degree. It's always hard to tell because there's not this alternate world without action. But globally, emissions have continued to tick up year after year, although the richer countries have been decreasing their emissions. But the poorer countries, thankfully, are becoming less poor and are thus polluting more. So we have this challenging, this tension between economic development and preventing climate change. We could certainly prevent climate change if we all became poor, but there's obvious reasons why that would be an unjust solution. So these emissions keep going up. We might be in a situation now where it looks like they're leveling off. That's hard to tell because of COVID, but we're looking toward the future. And if we want to keep global warming within, let's say, 2 degrees Celsius, which is the international agreed upon target put forth in the Paris Agreement of 2015, we probably need to eliminate all emissions by, let's say 2050, 2060 in there worldwide. And we're completely not on track to that. Despite 30 years of effort, maybe we've bent the curve a little bit. We're now at a stage where a handful of the richer countries are saying they'll reach zero emissions by 2050, but even that I'm somewhat skeptical of. So the first step, an early step has been saying, well, maybe we don't just reduce emissions, but we'll pull greenhouse gases out of the atmosphere. We'll pull carbon dioxide out of the atmosphere. So there's a variety of techniques where we could do that. To some degree, we already do that. You plant a tree, it grows, it pulls in carbon dioxide out of the air into its wood. And if you don't chop down the tree, then you've pulled some carbon dioxide out of the air. There's also more technological means, such as you can imagine like a factory, and it's filtering the air and it's pulling carbon dioxide out of the air and it's injecting it underground or making products out of it. These are possibilities. And it looks like this needs to be part of the mix to reach zero emissions. And it would allow us to, for example, overshoot what we need to do, like run a debt, and then later off you pay off your debt. Well, perhaps we could go to net zero in 2070 instead of 2060, and then go net negative for some time after that. The problem there is the models that assume that, the models that say, well, maybe we could keep warming within 2 degrees, assume such large amounts of carbon dioxide removal later this century that it's pretty hard to believe that this could take off, right? You look at the numbers and it's upwards of 10 gigatons per year, and that's just enormous. To give a sense of scale, the amount of food that's grown worldwide seems to be something on the order of 3 gigatons per year. So take all the farms out there and all the feedlots and cattle, and then triple that, and then you have this new industry of carbon removal that has to go on for decades. Possible, but it makes me nervous. You don't want to bet on that. So some scientists are saying, you know what? Maybe we need other options. And one possibility that's motivated scientists, actually for some scientists for decades, say, well, volcanoes cool the planet. We've known this for ages. Now, when a volcano erupts, it releases particles of various sizes. The smaller ones stay in the atmosphere longer. They block a small portion of incoming sunlight. And a big volcano, such as Mount Pinatubo, which was the last real big eruption in 1991, I believe, cooled the planet by about 1 degree Celsius for about a year. Think, 1 degree Celsius. Well, that's the order of magnitude we might need to take the work to perhaps compensate for really the worst effects of climate change. So instead of a 3 or 4 degree world, we might end up with a 2 or 3 degree world, or perhaps 2 degrees if we use 2 degrees of cooling. So that would be called solar geoengineering or solar radiation management. And we know it would work in the gross sense of the word. We know it would cool the planet because volcanoes do. And the idea would be to somehow inject a similar substance into the upper atmosphere. The stratosphere would be preferred because you're above the weather there, and then the material would not fall out of the sky for quite some months. And you can inject a sulfur substance, sulfur dioxide, which is what volcanoes emit. And so we have a sense, well, this would work, and it's not too environmentally terrible. there are some drawbacks to that. And some other substances are being researched, and there may be some other means to do solar geoengineering. There's a couple of other ideas that are being kicked around, but a lot of the attention focuses on this so-called stratospheric aerosol injection method. So this has been researched through models. There's been a couple of small-scale outdoor tests of equipment and effects, and that's where we're at in the year 2020.
Thank you for giving that summary. As you said that, what I was thinking about was some of the ideas that I was hearing about on your blog about why this idea is still controversial, though it has a lot of potential, as you mentioned, for the urgent situations that we're heading towards. And oftentimes, what I saw you bringing up was two key issues. One of the misinformation regarding this topic,
Yep.
and I'd love to hear a little bit about that. And then the other was the moral hazard problems, the misaligned incentives of why we should do this instead of actually stopping to fix our current practices. So would you be able to speak a little bit to those two issues?
Yeah, sure. I'll try to loop around to those two issues by way of saying that solar geoengineering has been very controversial and has received quite some resistance. And I think this comes from a variety of origins. A good portion of this resistance, I think, is grounded in what has been called the moral hazard concern. It's not an accurate term for a variety of reasons. It's not a moral issue. And the term moral hazard comes from insurance economics. But that's a term that is often called, and this is the fear that if we start taking solar geoengineering seriously, research, development, high-level conversations, and perhaps even its use, that this will take the pressure off of cutting emissions, which should be the highest priority. And everybody who researches solar geoengineering and calls for its research agrees that cutting emissions needs to be the highest priority. For all sorts of reasons, solar geoengineering is not a long-term solution. It's a temporary addition into our toolbox of responses at best. And there's reasons for this having to do with, for example, ocean acidification, and that solar geoengineering does not perfectly compensate for climate change. And so this concern is sometimes spoken and sometimes not spoken. And it's to be taken seriously, but at the same time, I don't think it should stop us from researching. And looking backwards, one reason to see that is to look at something like the conversation around adapting to a new climate, which is another response to climate change that says, well, we're going to have a changed climate. We should build better infrastructure, teach farmers how to grow different crops, etc. And initially, there was resistance to considering adaptation for the very same reason, that it would take the pressure off of cutting emissions. But the climate vulnerable countries, the poor countries closer to the equator, said, no, we need to take it seriously because we're the ones on the front line here. And so it went up on the global climate change agenda. And there's no longer any talk that this is somehow undermining efforts towards cutting emissions. It's seen as a complementary addition to our toolbox. And I think that can be the way that we look at solar geo. And the other source of controversy is an underlying sense, particularly among environmentalists, that the right thing to do is to reduce our interventions in natural systems, and intervening in natural systems is the wrong thing. And this is an understandable meta lesson, if you will, from environmentalism, but it's not always true. There's all sorts of things we do to intervene in the natural system for human goals as well as for environmental goals, such as ecosystem restoration. But ultimately, a resistance to thinking about solar geoengineering for that reason is sort of like saying we're going to withhold a method to reduce risk. That is, we're going to increase risk in order to increase the probability that we do the right thing. But then you have to ask yourself, well, what would happen if we don't do the right thing? Well, someone's going to suffer. And it's not our generation, and it's not the people who are living in the rich countries who would suffer, but it's the next generation of people who live in the low latitude, poorer countries that are really on the front lines of climate change. So that's the reason I've been a little bit that I don't think that the moral hazard concern should stop the research of solar geoengineering. And to be clear, we're not talking about whether we should use it or not, but we just need to have more knowledge about whether this could be a useful tool in the future. Unfortunately, some opponents of considering and researching solar geoengineering have influenced the discourse in ways that I think are not only unhelpful, I think they're somewhat poisonous in the sense that ideas that might have a kernel of truth are misrepresented in ways that are inaccurate and repeated, and then take on something of a life of their own. And this has created a situation where those of us who think that solar geoengineering needs to be taken seriously must overcome not only a certain understandable resistance to this idea, but a significant amount of misinformation around the evidence and governance of solar geoengineering.
Yeah, and I was reading one of your research papers, I believe from 2016, that talked in detail about some of these ideas that are misinformed. So I'll be sure to link that in the description if people are curious to hear about that. But this finally brings me to the last area of the conversation, which is how we are prepared to regulate this phenomena on a global scale. And the two questions I have for you are, well, one, what is the status quo of these systems that we have in place? How prepared are we to internationally cooperate? And then two, how is the governance of geoengineering unique from other international environmental policies?
Yeah, those two questions are deeply related. So I have to think about both of them connected. And if we think about the prospect of using solar geoengineering, not researching it, which is what's on the table now, but potentially using it in, let's say, 20 years' time or 30 years' time, it's clear that countries are going to be the main actors in this area. Actors is a term that political scientists like to use, meaning the relevant players in the situation. Solar geoengineering is not something that you or I or Bill Gates or Amazon would roll out. It's relatively inexpensive compared to other responses to climate change, such as cutting emissions and removing greenhouse gases from the atmosphere, which is a benefit, but it's not so inexpensive that Jeff Bezos or somebody could implement it. Countries are going to insist that if anybody's going to make decisions about this is countries. Ideally, there would be a universal agreement, a global agreement among all countries regarding whether and how solar geoengineering should be undertaken. That would be the most legitimate option, or at least perceived as legitimate. But I think it's wrong to insist on unanimity in order to do solar geoengineering, because there you're giving a veto power to any country that wants that. We just don't know how sharp the disagreement among countries might be around decisions to use solar geoengineering. So we need to have some sort of a forum, for at the very least, exchanging views and information around this prospect, and perhaps decision making, or perhaps not. Decision making may remain somewhat decentralized. So whether there would be a United Nations agreement on geoengineering in some sort of council that makes the decisions or not is really up in the air. It's not a requirement. Part of the challenge is it's a little unclear where to start that conversation. A lot of attention goes to the current climate body, which grew out of the treaties. So you have the UN Framework Convention on Climate Change. It has two other treaties under it, so to speak, the Kyoto and Paris agreements. But it might not fit perfectly there for a variety of reasons. It might not necessarily be within its mandate, which is to reduce greenhouse gas emissions and to stabilize greenhouse gas concentrations, which isn't exactly what solar geoengineering would do. So it's a little unclear where this might take place. There's been some talk at the UN Environment Assembly, which is the governing body of the UN Environment Program, UNEP, which has been a place where international agreements often get their start. There's been some talk there. There was discussion a couple of years ago about whether to reach a decision, a research project, form a committee, make a report, etc. But that didn't take off. So on the one hand, we need a forum for discussion and perhaps decision making, and we don't have it. On the other hand, there's indications that the gears are turning, albeit slowly. Solar geoengineering is a bit odd compared to other environmental issues for a number of reasons. And let me make some comparisons. First, most environmental issues are local or national, and they're dealt with more or less okay by country. So you have a smokestack making some air pollution, and then nearby residents are unhealthy, and the government then can regulate the factory or hold it liable or similar activities. And then you can scale up and look at regional pollution, and countries tend to cooperate around things like acid rain, which was a problem about 40 years ago. In the North Atlantic region, shall we say, Northern Europe and North America, they cooperated. But then you start looking at the global problems, and you get these, you can think about things like climate change or ozone depletion. Stratospheric ozone was being depleted in the 70s, 80s, and into the 90s because of certain chemicals that are used that were depleting protective stratospheric ozone. And these are difficult problems to solve. They're so-called global public goods or global collective action. The players collectively together want to take action, reducing greenhouse gas emissions, reducing ozone depleting substances. But individually, each player has the incentive to do as little as possible and free ride on the efforts of others in the hopes, I suppose, that everybody else will do their part. And at the end of the day, of course, nobody does enough. And that's what we see with a lot of international, larger scale international environmental issues. Climate change, biodiversity protection is arguably like that. And if you've ever worked as a young student, for example, on a group project, it's very much the similar dynamic. The group wants a good project, but each individual person has it in their interest to sort of drag their feet and sort of hope that everybody else does it. It's a similar dynamic. Geoengineering is a little different. Solar geoengineering is a little different in that you don't need everybody to do something. If you want it done right, you only need one or a handful of countries to do it in a way that is more or less in the world's interest. And then you get into questions about, well, would it be in the world's interest? Would a great power like America or Russia or China do it in a way that's in the wider interest? A cynic would say, well, of course not. You'd ask them, then why wouldn't they? They can't adjust the knob, so to speak, for each individual country and say good weather here, bad weather there. Or would a climate vulnerable country, perhaps a coalition of India, Indonesia, and some sub-Saharan African countries form a coalition and use a modest amount of solar geoengineering in a way that reduces climate change globally? We just don't know. We just don't know. So the nature, the dynamic of the agreement that's desired or necessary is fundamentally different. I think in some ways it's I call it an easier problem to resolve, but that doesn't mean that it's not difficult.
Yeah, it's very fascinating to hear about all of these open questions and very interconnected questions between, say, the economic incentives, the political stakeholders, and the science behind it all on top of that. So I'm going to be very excited to keep on staying updated with how the research progresses here. And finally, if someone wants to learn more about the details of this problem, I'll definitely link to your blog and the research papers that I found. And if you have any other resources, for instance, maybe some organizations that have effective information about this, where might people go?
There's not a clear central location for information on geoengineering. I'll say a couple of sources of general information. There is a group called the Harvard Solar Geoengineering Research Program, which is more or less what it says. It's a research program out of Harvard that's done a lot of research in this area, and their website has a blog, and most of their research papers are put up there for free, not behind a paywall, so to speak. There's a group called the Carnegie Climate Governance Initiative, which is an international non-governmental organization that's been working for a few years to encourage international conversations toward the governance of geoengineering, which, just as a way of a note, the term geoengineering there includes both solar geoengineering and large-scale carbon dioxide removal, which I mentioned earlier. Those are a couple of good sources. Of course, one can also browse Twitter. There's a few informative individuals to follow. One must be careful, though. There is the related conspiracy theory that solar geoengineering is already happening and has been happening, which is, of course, false. But if one does a search on geoengineering or solar radiation management, if you start to see a talk of chemtrails, the trails left by airplanes are actually chemicals being rained down upon us, that is an indication that that is not a reliable source.
Great. We really appreciate those tips, and I'm sure that people who are more interested can learn there. And finally, I really appreciate you taking the time to join me today, because it is very, very open, this field, and I'm thinking that a lot of people who are my age now will be the ones thinking about how to join in later on and contribute to the questions that keep on arising. So thank you.
Glad I could help. Glad I could help. It's been a pleasure.